Hi, welcome back again to the Ivory Tower Collections. We're going to be looking at a 5200 today. Now I know it may not look like an Atari 5200 you're used to, but that's because I already have the top cover removed. It pretty much came to me this way. This is a 4-port unit, as you can see here, and I only know of one real issue with it to begin with, and that is the fact that I believe it doesn't have any audio, but supposedly the rest of it works. What we're going to do here is we're going to check a couple of components as far as the power cable that I've got ready to go. I'll run the diagnostic cartridge through it real quick just to make sure that visibly, as far as like the graphics and things like that are concerned, it looks like it's okay. I'm not going to worry about the controllers just yet. That might be something I do separately as far as the calibration process on a 5200. So anyway, we've got this 5200 sitting here on the bench, and we're going to check a few things on it and just kind of see what we can do. I don't know that I'll be able to knock this all out in one shot, but we'll give it a try. Okay, before we get too involved in this, it would be a good idea to make sure that the power supply that I have is going to do the job. So I've already got the 5200's power supply plugged in. Which on the case of the 5200 it's basically like a separate brick. But here's the end of the power cord. Now, I do have some concerns about this power cord. I can see that part of it is actually chipped, and when I think about this, I don't think that's too uncommon on these older 5200 power supplies. So, well, we'll just check it out. So I've got my voltage, or I've got my meter here in DC. So I'm going to put the tips in here and let's check and see what kind of a reading we get. So we are reading right at about 15, almost 15.5 volts. Now that might seem really high, but this being a 4-port unit, I believe that the power supply on this unit is the 11 volt version. And so once you put a load on it, once you've got it plugged into the 5200, all of that drops significantly. And then at that point, that's where you really want to need to check the voltage, pretty much at the voltage regulators itself. So again, this particular one uses a funky switch box. So now what I'm going to do is plug the power into the switch box assembly, and we'll see what happens with this 5200. So what I've done now is I've got this 5200 with its switch box connected up, and I have my test cartridge in place, and we're just going to try to power it on and see what we get. Well, we're not getting anything. We're not getting anything on the screen as far as indicating it's on, and additionally the power LED is not lighting up either. However, I don't know if you could hear it in the video or not, but the switch box is clicking, which tells me that the switch itself is obviously good, because it wouldn't, if the switch was bad, then it wouldn't be able to detect that I am actually depressing it to actually kick the switch box on and off. So what I'm going to do now is we're going to take the rest of the top cover off of this 5200 and just check for some voltages in some places. Okay, so a bit of an update here. I found out part of the issue. So it actually turns out that it does power on just fine. Because of the issues that this came to me with, again, I know that it has problems with the audio, and I know that the previous owner had attempted to make some repairs themselves. And what I discovered is there's some wires on the bottom or there's a wire that's been added to the bottom to try to correct a burned out trace, and that was apparently shorting against the bottom RF shield, preventing the system from powering on. So kind of a dangerous situation, and I'm glad I saw that and caught it. But in any event, once I took the RF shielding off and made sure that that wire isn't touching anything now I'm able to at least power it on. However, you'll hear some static in the audio because, again, there's problems with the audio circuitry. Pretty noisy. So I'll turn that volume down a bit. So I know it's going to be kind of hard to see on the screen, but there is a square here, and that's because this is part of this is actually Pete's test cartridge, and this is where you can check the controller cursor functionality on the screen. I mainly just wanted to make sure that this 5200 would power on and give me something, and it looks like at least the logics are in place. So now it's just a matter of figuring out if we can figure out what's wrong with the audio section next. And boy, don't I feel silly. So immediately upon removing my cartridge from this, and you would think I would notice this when I'm taking the RF shield off. I'm sure some of the viewers may have already have noticed this, and if you didn't, well then I'll point it out to you. So obviously we're not going to get any proper audio and some other logic issues because there's something very, very important that's missing from this 5200. And my hand might be partially covering it right now. Right here, we've got ourselves an empty IC socket. What the heck? Well, I'm going to have to guess that the previous owner, when they sent this 5200 to me, knowing that it wasn't functioning, decided to remove the pokey chip off of here. Now, in the case of the 5200, the pokey is responsible for not only the audio, but is also responsible for controlling the controller inputs as well. So without the pokey chip in place, this 5200 is never going to work properly because obviously it's going to require audio, which is what we're here to try to troubleshoot, and it's going to need controlling, or it's going to need functional controllers as well. None of that's going to work without this pokey. So what I'll probably have to do is put this video on pause for now and see if I can source another pokey. I don't know if I have any just laying around. I don't believe I do. But I'll see if I've got a pokey somewhere to at least pop in here for further testing. Now, I haven't sourced a replacement pokey yet, but I thought before we do that, we'd just go ahead and take a look at the bottom side of this board just to take a look at what we know is going to be a problem for us going forward. So, let's see, not sure if you can see all this, but there is a obvious wire that's been added here, this red wire. I'll see if I can get my camera to kind of focus in on that for you. So what we're looking at here is basically the audio section, which you can see there's this red wire clearly that's been added, and just a lot of other solder work that's going to need to be, basically I'm just going to remove all this and just kind of take a look at what we have. But it's apparent that some traces are obviously missing. So we'll have to replace, we'll have to put some new jumper wires in place to repair that part of the circuit. But yeah, I mean, all of this is responsible from the pokey chip into the audio, into some filter capacitors, some little poly caps that are on the other side, before it goes into the RF modulator section off to the side over here. So yeah, what I'm going to do is I'm going to go ahead and just kind of remove this stuff off of here right now because we know it doesn't need to be there, and just kind of remove these wires off of here. There we are. Okay, so we've got that off of there. Let's take a look if there's anything else here. Got a large lead poking up through here. I've got a blob of solder here I'm not quite sure about. Looks like another lead that's attached to some point over here. Let's see if we can potentially wick that out of there. Might use some desoldering braid here for the job just to help out a little bit. There we are. Okay. And I'll do the same with this blob of solder I see here. Now it's possible that these two pins are supposed to be tied together, but I don't think this was done at the factory, so we'll take a look, or I'll take a look at the schematics on this a little bit later just to verify if there was a trace between these two originally. There we go. Get that all. Alright. Got that off of there. Got a little bit of solder that's kind of hanging around here on this ground plane. Just get that off of there. Good. And that's pretty much got it. Now we've got some big globs of solder still left on here, but that's certainly better than it was. And I realize you guys can't see the details on this, and I do apologize. I'm just kind of trying to clean up some stuff a little bit here. Yeah, let's see, this is the other one that I got off of here. Okay, so this is going to what? We'll find out on the other side. I bet you this goes to those poly caps that I was talking about before. So it looks like for sure those poly caps, pretty sure that's what these leads are for. So if I carefully turn this over, and let me get this into frame so you can kind of see what it is that we're going to be looking at here. Get this RF cable out of the way too, as much as I can. All right, let's see if those can be seen or not. They should be. They're right here next to, they're right here. This is what we're talking about. These are the poly caps for the audio. And so what it looks like has happened is the original traces on the bottom side of the board that these were attached to and came from other points, I believe off of these resistors back over to here. And then further on down the system and eventually into the RF modulator is just kind of gone. So what I'll do is, again, I still need to source a pokey for this thing because it's missing. But what I'll do is once I get a pokey in place, or even before I do that, I'll go ahead and take a look at some schematics and just find out where the nearest points are from one spot of the board to one end of these caps and then on through the other, just to verify that that part is good. So maybe make it look a little nicer as much as we can. Obviously, like I said though, as you can see on the bottom, those traces are basically completely gone. So yeah, we'll just do what we can to repair that up and go from there. So what do we need to do to check this out and to troubleshoot it and verify where the traces are broken? Well, you really need two things. First of all, these are some snippets I got out of the 5200 service manual. And one of the things you're going to need for sure, the board layout. Now, this is showing you where on the main board the components are labeled at. Now, I already happen to know that the two capacitors that we're dealing with happen to be C13 and C14, as you can see right here. And the reason why I have this view is because this correlates and matches the actual view on the board itself. I'll see if I can pull this up so that we can take a look at it. So here's a different one right here. And the area that we're going to be looking at specifically is right here. So you can see that the way these components are laid out, this is C13, this is C14, there's an inductor here, there's these two transistors here, the audio coil adjustment here, and a row of resistors. That actually matches what we're looking at right here. That becomes important because on the other side of this, of course, is the schematics. Now, why are we concerned with the schematics? Well, we need to know where C14 and C13 connected in relation to other components in the same area. That's why that's so important. So let me get something here to point with. Now this is a section that I took out of the service manual for the 5200, and specifically this is the audio subsection here as far as the schematics go before it goes off into the RF section off over here. So I just clipped out the part that we needed that we're going to be looking at. Here is C13 marked right here, and here is C14 right here. Now there's a goof in this picture because capacitors are normally drawn with like these lines. You see how we have these two lines that break up across? That indicates that it is basically a non-polar or bipolar capacitor of a set value in this case. And C14 should have that same thing listed right here off of this line, but it's missing. Now I've seen other schematics later on in other revisions that do show that. However, when you blow those up, those scans up, then the letters and the numbers are much blurrier. So this is a clearer picture from the older original schematic, but it's missing that. So you just have to trust me that these same two sets of double lines here that we have in parallel above and below each other would also be present over here. So this is C13, this is C14, those are the capacitors that we're concerned with. And specifically what we need to do to read this schematic is we need to know what points on these capacitors were connected to what. So if we start with C13, which again is the capacitor that was on the top, right here, okay, we can see that it connects to one leg of R39, which is a 1K ohm resistor, a 1K resistor there, and also the other leg of it attaches to R41, which is an 18K resistor. And those are the only 2 points it connects to. Now why do I know that? Because these solid filled in circles indicate traces or other components that component directly connects to. You might see in other schematics where you just see lines that just go across each other, but they don't actually have dots filled in like that. And that just means that the trace goes over it or under it, but it's not actually connected to it. So if you've ever wondered about that in schematics, now you know. So that'd be the one thing we'd need to do, is to verify that one leg of C13 connects to where R39 is, and that the other leg of where C13 is, or capacitor 13, connects to where R41 is. So right there we want to look for 39 and 41. And where do we know where those are? Well, that's why I have this here. So let's see, R41. R41 is right here, and R39 is way over here. So already we know that one leg of C13, it doesn't really matter which one, we just know that one of these legs of C13 should connect to both R41 and R39. Now it's not always true, but in most cases, the way boards are laid out, they're going to try to make those distances fairly short and straight to each other. So it's likely that R41 on this end would connect to R13 on this end, and then the other end somewhere on these will also have continuity with probably the end of R39 over here. So that's one thing that we definitely want to check. So again, R13 or C13 should have a connection to R41, and then it should also have a connection all the way back over here to R39. So that's one thing we'll need to check. And let's go ahead and check that out right now, since we know where it needs to be. Okay, here we are looking at the zoomed in portion of that same circuit area that we were just looking at on the board layout. And again, we're concerned right now with C13, which is actually right here. This is the location for C13. Now I've already removed the capacitors out of this just to make it a little easier, and because I already knew that we had broken traces, and it was easier to see where those traces are broken both on the top and bottom side of the board with those capacitors removed. I might also replace them too. It's obvious that there was a lot of heat that was used to try to repair this, because there is some physical damage and actual pads missing. So just to be on the safe side, I might even replace these capacitors. So anyway, here's C13, and again, what we know from what we previously looked is that one leg of C13 should be connected to resistor R41 and resistor R39. Now, R39, we can actually kind of see it. It's right up here. I don't know if it shows up on my camera, but it is actually labeled. Actually, all of the silk screens label this, but in the case of the resistors, those silk screens are actually underneath the resistors themselves, so you can't really easily see them. That's why it's important to have that other diagram with the board layout that I showed you before. Just to clarify, with what we just found out a second ago, we know that our connection point on C13 from here to here appears to be cut. It's not actually working the way it needs to be. So we've got a break somewhere along there that we're going to have to fix. And then the other thing that we know is that C13 from this end over to C39 over here is working. So that side's good to go. No problems there. So now we're ready to take a look at C14. Okay, so here's the schematic again, and we want to focus now on the section for R14, or for capacitor 14. Now, capacitor 14 is more of a complicated mess. It connects to a lot more components. Let me show you. So capacitor 14, again, it should be here. Now, I know it's missing, so let me just try and make a couple of little lines like that. I know you'll just have to trust me, but that's where capacitor C14 would be. Now we know that one side of capacitor C14 actually connects to two components. It connects to inductor L2 on one side, and it also connects to one of the legs off of transistor Q4. Again, we can see that because one side of this NPN transistor meets up to here, as does one side of inductor L2, and again, we know that one leg of C14 also connects to that. So one side of capacitor C14 should connect to two, or have continuity with two devices there, or two components. The other leg of capacitor 14 is connected to a lot more stuff. For starters, if we follow this right down here to this first connection and follow this line, it should connect to one side of capacitor 10, which is also marked right here, again with the same little parallel lines across each other. It also should connect to component R43, which is a 6K resistor, or 6.8K resistor. And it should connect to the opposite side of transistor Q4. Again, all of these components indicate that they're tied together in some way electrically in the circuit. And it's also attached to R42, which is a 9.1K or 9K resistor. And again, it attaches over here to R41, which is an 18K resistor and one side of capacitor C13. So the other leg of capacitor 14 connects to a whole bunch of stuff in the chain here. Basically, it connects to 1, 2, 3, 4, 5, 6 additional components on the main board together. So we're probably going to find that the biggest bulk of our failure as far as missing trace information on the board is probably going to be from capacitor 14. So that's the next thing we're going to take a look at, is to see what part of capacitor 14 is talking possibly to any of these. I've got a feeling pretty much none of it, because I've already looked and the pads were missing on the board, but let's take a look anyway. We're now looking at the board again on this 5200 in the audio section, and now we want to take a look at C14, which again connects to quite a few components. Now we know that one leg of C14 should be attached to two devices. It should be attached to one side of Q4, which is this transistor right here, and it should also be attached to one side of this inductor right here. I believe this is L2 right here. Let me just make sure real quick by moving over. Yes, that is correct. And if I was to hazard a guess, it could very possibly be this side here. But again, I happen to know that the pads are pretty much gone on this thing, so we don't really have much left. But we'll take a look. We'll see if we can get any continuity to anything. Nothing at all. Looks to be completely dead. Now let's make sure that I'm looking at that correctly. So I have another 5200 board here. See if I can get my focus to adjust on that. It may not. So let's try this again. This side of C14. Got continuity there. And to transistor Q4, just like we expect. This side of capacitor 14 needs to connect to capacitor C10, and it does, which is right here. It also needs to have continuity with R43, which is located, I believe, over here, and it does. And then we also know that because it needs continuity with R43, it should also be talking to the other side of capacitor C13, which is right next to it, and it does. And we know that capacitor C13 also talks to R41, which is right here, and so we have continuity to all these components right in this area from this side of C14. The last component that we should have continuity to on here is to the other side of Q4. So nothing there, and there we go. Whoops, sorry. So we're looking pretty good there. We know where our continuity and where our connection should be on a good known board, and by looking at the schematics. But what we have now determined is that on the actual board that we have sitting here, we know that this side of C14 was connected to, we were getting continuity on either side of the inductor and to the bottom of Q4, and we've got nothing. We're totally dead. And we know that the other side of C14 over here should have continuity with this side of C10, which we have nothing. And it also was connected to R43 and R41, which again we have nothing. And it was also supposed to be connected to C13 on this side. And then finally the top of Q4. And again, we have nothing. So there's quite a bit of repair that we're going to need to do with C14 alone just to get it to connect where it needs to. So let's get started.
In their headsets, it sounded like a woo-woo kind of a noise.
Sounds like, outer space-time music.
Over the course of an hour, they mention it multiple times. This is not just some anomaly. This is something that they're all really hearing, and it's really weird.
generation of cartoonists who would become the animated stars of the 1920s and 30s. Thomas Edison had been producing films since the 1890s. He also...
Okay, if you were paying attention and saw all that, or some of that. So I went ahead and replaced this main filter capacitor up here. It's a little crooked, didn't realize that until just now. I might hit that with some heat on the bottom side to straighten that out a little bit, but it's okay, it's not going to hurt anything. I went ahead and replaced out these two capacitors here on the board. Bring it in a little bit closer so we can see it a little bit better. So yeah, I replaced both of these capacitors. I had to replace a trace that needed to go from here to here on between the two capacitors, so I just used a small piece of enameled wire wrap to do that. And then on the bottom side of the board, see if we can get that zoomed in here. So on the bottom side of the board, I basically had to, in some places I just made sure that the lead was bent over far enough to just connect where it needed to go. And then on this one here, it needed to connect over to, most of the trace was still intact over here, so I just had to run the lead all the way over till it connected, and then it connects up to all the other components that it needed to without issue. And then just to make sure it doesn't short out against anything else, I've got a small piece of shrink tubing across that. And then the other side of the capacitor leg from C14 needed to connect directly to the resistor pin over here. So that was just easy to just stretch it over there, solder it down, and clip it. So yeah, no big deals. Looks like I think we're going to be okay. Now there should have been a solder pad here, which is the other leg of C14, but you can see that it's all scratched away and it's basically gone. But luckily, there aren't any components that attach on the bottom side of the PCB for that leg. And the only real parts that needed to attach are from here to a trace that runs along here. So I just made sure to scrape off some of that trace to make sure it runs along and has a nice, good, secure connection there as well. Plus that trace also runs down to down to here. So yeah, should be good to go. And then you saw that I put a replacement pokey in place. So at this point, I guess I'm ready to go ahead and give it a smoke test. We'll see where we're at. Okay, here we are back again. I've got the 5200 connected up. I've got a fairly crappy controller attached to it that definitely has issues and needs to be rebuilt at some point in time. But for the purposes of what we're going to check out here, it will work perfectly fine. So I've got my test cartridge in place. I've got a replacement pokey installed. And I've got the funky switch box hooked back up into the RF cable here. And we're ready to see what happens. Again, I've repaired, or hopefully I've repaired the audio section over here. So here we go. All right, well, maybe you can see that, but I've got cursor control, so I know the pokey looks like it's working. And there's the color display, the color bars. There's some audio. Well, I would call that a successful test. It would look like we have audio working and most of the logics are in place. Obviously, like I said, I don't have a very good controller here. But otherwise, I would say that this 5200 should be good to go. Thanks for joining me this afternoon. I will catch you guys next time.